Hey guys, welcome to my channel. In this video we'll be discussing a challenge from ROP Emporium called fluff. And yep, we'll read the description. That is, the concept here is identical to write for. Write for is a challenge in which we just wrote a string into memory and then we set that as an argument to system. So that is write for challenge, and then the only difference is we may struggle to find gadgets that will get the job done. If we take the time to consider a different approach, we'll succeed. Click below to download the binary. I've already downloaded the binary, and you might also observe this change. I've increased my font size because my friends told me to increase it because it was hard to see through the screen, I guess. Anyway, so we'll run the binary. Pretty much the same. We'll analyze this in GDB because to get a more broad view. So in main there is nothing different. It's exactly the same as the other challenges. So let me also see pawn me. Yes, it's exactly the same. We don't have much difference in the structure. Maybe we have different functions, I guess. Yep, we have things like questionable gadgets, useful function, pawn me, and main. So we saw pawn me, we saw main, and we also know that useful function is just going to have that system which we can use in our later exploit. But I don't know what is there in questionable gadgets. Yep, questionable gadgets. Okay, you have a lot of gadgets, but this time it's not direct. It's a bit confusing because we know that this is the only way to write the string into memory. That is basically giving r11 as our string /bin/sh and giving r10 as one address. So maybe we can write an exploit or the basic of our the basic structure. We know that it's 40 bytes. You can even cross check that because the structure has not changed. 40 is 40, but this challenge is a bit hard to understand, so I'm going to write the steps what we have to do here. So somehow we have to get r11 as /bin/sh. How can we do that? The first thing that comes to my mind is this function. This is XOR. We have already dealt with this. So this function is just going to make r11 0, because when you XOR something with itself, it is just going to cancel out all the bytes and you are going to get 0. So r11 becomes 0, and we can exploit this thing, and maybe we can jump here so that r11 becomes r12. So that's because when r11 is 0 and when you XOR something with 0, you get the same value. So when you have r12 as the string, and when you go here and when you come back, r11 will be 0, and after executing this, r11 becomes the string. So that is going to be our first step. Make r11 0. Then r11 should be equal to r12, which is equal to the string, and then before that r12 should be that string, and then that's all set, I guess. r11 becomes the string finally, and then maybe we can take care of r10. So r10, how can we do that? Again, maybe we can make r12 the address of address from the data section, any address which is free, and then maybe again we have to XOR R11 because it will contain some yeah, the R11 will be the string, right? So we have to zero that. But once we zero R11, yeah, that's nice. Maybe we do this after, when we get the address, because this function is still more better, because it's just going to change what is in R11 to R1110. For example, say R11 contains the character A, R10 contains the character B. After this function, after this command gets executed, R11 gets the value B and R10 gets the value A. So it's like an exchange program. So maybe we can try that first. Yeah. So R12 make it the address, give some random address, and R11 make it 0. Then after that we are here right now, R11 making it 0. After that we jump to exchange, because we need R10 as the address. So we exchange. What are we exchanging? We are exchanging R11 with R10. And then after exchange, pop, and yeah, rest of them are same. So we get R10 as the address, and then we do these things. Yeah, R12 becomes the string. After popping it from here, R11 will make it 0. Then we come here, so we make R12 0, and yeah, pretty much the same. Okay. And also, once we jump here, we execute these two. We don't have to worry about them, but XOR byte PTR, we have to worry about this. So I'm going to give R1 to be as 0, so that this does not interfere with our string. Anyway, so let's craft our payload. First things first, R12, we have to pop R12. Pop R12. Key 64. But we don't have the string, right? I'll just open up IDA 64. Fluff, and okay, just to get an address from the data section. Go to hex view. This address seems pretty nice. We can just take this address with this. I don't know if I copied it. Oh my god. Shit. I did not copy it. Bad me. Reload the file. Okay. Sorry guys. Next view. Okay, whatever. Just take, yeah, this time we'll take this 601000. Copy. I'm going to copy this first here. That's nice. Oh, it's hex, right? I always forget to make it a hex. Now I guess we can close it. Don't save it. Thank you. And yep, we have filled it with the address. Now we have to make R11 0, buffer plus equals to P64, and buffer plus equals to, now what do we do? After that becomes 0. Okay, there's a pop R14. Maybe we can give some value in pop R14 just to execute it properly, and then P64 will make that 0. Then 22. So we'll return to, we have R12 as that one, so what can we do? I guess this function, because this will make no, yeah, this function will make R11 as R12, because R11 is 0 from this thing 22, that is this byte, I mean this address. So R11 becomes 0 and R14 becomes 0, and then after you go here, R12 contains your address. When you go, I mean R11 contains your address. When you go here again, R10 contains your address, right? But wait a minute, 2F. Okay, there's a pop R12, so we have to take care of that. And then we jump to that function, and there's one more pop, so P64 0. It's becoming a really long ROP chain. Once we go here, return. Now R10 is set, that is, it's our address. So again we pop R12 just as we discussed. P64, that buffer plus equals to P64, and now again we jump here to make R11 0, and we have a pop, so P64 0, just to make the pop R14 0, I have given 0 here. And we have one more return. Where do we return? We return to this function, buffer plus equals to P64 and that function 2F, and you have a pop plus equals to P64 0. And where do we go? We jump to this function, so that I guess everything is right. 2F, and you have one pop, that is 0, and you jump here. R11 becomes the string /bin/sh, but we did not give anything. That's dumb of me. Wait a minute, where's pop 32? I need to give the string /bin/sh, and then you do 22, go to 22, where is 22? 22 is here, yes, it becomes, R11 becomes 0. Then you have a pop and 2F, where is 2F? 2F is here, R11 becomes R12. That's nice, I hope it works, I'm not sure. P64, and we have two pops, P64 0, sorry, buffer plus equals to P64 1 0, then P64 another 0 for two of them. We don't need to worry about this because R12 is already 0, so I guess we can now just pop RDI ROP gadget. I'm using ROP gadget, fluff, where's pop RDI, buffers plus equals to P64, popping the RDI, and inside the value of RDI we give the address that points to the string /bin/sh, and then once popped RDI, this time I'm not forgetting the system, okay? GDB the system, this is the value of the system, and yep, t dot process / fluff t dot here guys, send line buff t dot interactive. Hope this works. Unable to save. Why? Save it. Why is that so? Cat ape dot py. Okay, I'm having technical difficulties, I guess. Save this. Why is it unable to save it? Anyway, I'll copy this file. Save it at least now. Close without saving. Now cat ape.py. Yes, there we go. Python ape.py. Oops, I forgot. Save it. Buffer is not defined. Oops, I am missing something, I guess. Yes. Let me go to that thing again, and this time I'm not going to just pause the video and figure it out. I'm just trying to PD useful, I mean questionable gadgets, right? What was that again? Questionable gadgets. Okay, let me go from first. What is this do? 32 goes for pop r12, and you give that as the address, r12 as the address, and then go to 22 is this, r11 is 0 here, r11 is 0. Then for what is 2f is r11 and r12, so r11 becomes r12, so r11 is that address, and then you have 40 840, so that is going to be this one. I'm going to do exchange of r11 and r10, so r10 becomes the address, r10 becomes the address. There's a pop instruction, and that's one pop. Okay, 32, where is 32? 32 is here, and I put this as the thingy, and where is 822? 822 is right here, r11, so r11 gets zeroed, one pop, and 84e, where is 84e? It's right here, but wait a minute. Yeah, 832, that is right here. We have popped r12, and this is r12 is the string. Why do we go to 22 then? 22 we go for, why do we even go there? We have to go here, right? Okay, yeah. r12 becomes 0, and then in this function r12 becomes 0, there's one pop, and 2f we go to this function where r1 to r11 becomes r2 because r11 is 0, and then after that there is a pop instruction. Then we go to 84e, yeah, we pop two things, XOR them, and then for E, and we pop. Oops, I think I found out the mistake. I did not copy the ROP gadget pop RDI, I guess. Pop RDI, this is pop RDI. Yes, I did not. Sorry guys. Now at least I guess it's going to work. Maybe. Yep, it works. Silly me. Anyway, we got the flag. Nothing to worry. Let's just be happy we got the flag. And boom, so this was fluff, and in my next video I'll be discussing about pivot, and that challenge is also pretty easy, but I have to explain you guys about some of the basic terms like stack pivoting and what is that. And I guess that's it. Happy hacking, and please do like this.